All right, well, let me continue on here, get a share screen going. I'm going to try this unstable building one more time, see if I can get it to fall over for you. It wasn't tall enough in the last case. So you can see the things are going awry here. Even though everything is perfectly set up, eventually this thing just kind of falls apart. All right, so that convinced you. Falls apart. So the other issue here, I'll save that. The other issue here is this chain test, where if I add these things and if I subtract things, there's this kind of jerkiness that occurs here with the chain. And I had a different idea. Instead of changing the number of links, instead just make each link longer or shorter. And one simplification this buys me is that I can now use the simple square bracket arrays, since I no longer need the add and remove at features of the list data type. The update function is now simpler. Just calling this lengthen function that lengthens or shortens it by a certain amount. Also, since I was doing it this way, I could use a get key instead of get key down. And then that way, holding down the key lengthen it. The lengthen function just simply loops through all the links, adding scalar, the argument here, to the Y component of the local scale through a temp, of course. And I'm clamping it to a range of 0.1 to 2 so that we don't get too short or too long a chain. One gotcha that I wrestled with for days was that if I didn't reset the joint's anchor and connected anchor by reassigning them, the joint's positions would not rescale with the link. So all I'm doing here is I'm saying temp is the joint's anchor, and then joint's anchor is the temp. Temp is the joint's connected anchor, and joint's connected anchor is the temp. So I'm not changing anything there, but that reassignment turned out to be critical for the rescaling. And I literally wrestled with this for several days. For the sake of the game, I have a scoring mechanism. Basically, we just calculate the average Y position of all the blocks and store that as base score. And then as the building is knocked down, we recalculate the average Y height and score that as a percentage as the building is leveled. Additionally, the arm of the crane is damaged so that when it's hit by or hits one of the falling blocks, and this is done with arm damage, which is just has non-collision enter. And if you tag the wrecking ball block, you can have it hit the arm and damage it as well. So let me show you the new chain. Here's the new chain, which now has always the same number of links. And if I make it longer, the links just lengthen out. And if I make it shorter, they just get shorter. And it's still maybe a little jerky because we are doing things. But this chain behaves a lot better than the other one does in many ways. Somewhere here is a chain test with both of them side by side. Whoops. Both of them side by side so that you can see the two of them working and decide which one you like better. You're welcome to use either one. So I'm going to stop sharing again. Oh, wait, let me show you. The play here. Nope, that's not it. That's the old chain. Here's the new chain. I will hit it eventually. There you go. Okay. So if my arm touches any of the blocks, my arm health goes down and my score does such and such, and I can see what the angle of the arm is and what the cable length is as I lengthen and shorten it. So good. Okay, I'm going to stop sharing here and I'm going to end the recording and I'll come back in with a little bit more next time.